We are ECE Group 2207, working on the path planning with deep neural nets project. This is a joint project with the CSE team. We are the ECE team. Our faculty advisor is Dr. Shalab Gupta. The members are myself, David Nazardo, Matthew Piotrowski, and Dennis Lerng. And as I said, this is joint with the CSE, whose advisor is Dr. Songyun Hong, with the members Everett Grethel, Michael Zhu, and Ethan Afobi. Our sponsor for this project is Mitsubishi Electric Research Laboratories, or MERL, and our point of contact is Carl Berntorp.
So the main overview of this project is that we are working on a patent that Carl developed, where it takes sensor data from a car, runs it through a deep neural network, and then produces an output reference trajectory. To do that, we are using a scale model RC car along with a Google Coral Edge TPU to take the sensor measurements.
All right, here's our car prototype with all our sensors and components. We have the LiDAR here that would feed into the Raspberry Pi. It will run on ROS that will feed into or display a SLAM map using the LiDAR data. Here we have our IMU that would send the data into the Coral Edge TPU that we have here. And we also have the camera that's connected to the TPU. And we have a script on the TPU that will display the acceleration data from the IMU and the camera for object detections of a future implementation of a neural net. And they will all be timestamped to be used by the neural net. And here we have the receiver for our manual controller with our voltage monitor used to power the onboard components.
So here's the car. Down here is the brushed DC motor and the electronic speed controller that controls the steering servo motors and the DC driving motor. Here is the remote control that we're able to use to drive the car when it is in data collection mode. So to do that, all we do is flip the switch to turn on the electronic speed controller. Those beeps you hear confirm that it is connected to the remote. And when data is being collected by the Raspberry Pi and the Google TPU, we can just steer the car this way and drive forwards like that. Forwards and reverse, and we can steer around the room.
And here is our 2D LiDAR running on a robot operating system node running on a Raspberry Pi. And it's taking 10 samples per second. And here's the SLAM map that it generates. This will not be shown when we're running the car live. However, this will be sent to the TensorFlow model running our neural net. But as you can see, this maps the environment. So this point right here will be me. So if I step back a little bit, you see it move back. And then as I step forward, you can see it move closer to the center point. Okay, so here we have two terminals. In the first one, we will run the snapshot command. And this brings up our camera that's running on our Google Coral Edge TPU. And then we have the ability to take pictures or quit out of there. And now in this terminal, we will run the script for the IMU. And the IMU is the inertial measurement. This takes our linear acceleration that would be fed to our neural net. This would be in terms of X, Y, and Z positioning. So if I move the car, you should be able to see some movement. And that is how that works.
So shown here is a video demo of the CSE team's neural net running on the Carla simulator. As you can see, the car that is driving is staying within the lane and not approaching the car in front of it too quickly. The mean squared error for the model that is shown here is about 0.05, meaning the output very closely follows the recommended input. This is the model that is currently uploaded to our TPU on the Model RC car.
And this concludes our ECE 2207 project overview video. Thank you for watching.